Hello, in this video I'll be working through Unit 3 homework problems 14 through 24. And these problems mainly deal with the product rule. But number 14 asks us to rewrite the function f of x as a polynomial and then apply the power rule. So f of x is written as the product of two functions, but we're going to expand this, so we will distribute or FOIL our first, outer, inner, and last to rewrite this as a polynomial function. So I get x cubed minus 3x squared plus 2x squared minus 6x. And now that it's a polynomial, this is really just the sum of a bunch of power functions, so I can use the power rule to find the derivative. Derivative of x cubed is 3x squared. Derivative of negative 3x is negative 6x. Derivative of 2x squared is 4x. And derivative of negative 6x is negative 6. Combining like terms here gives 3x squared minus 2x minus 6. So there is f prime of x. Now number 15, we have the same exact function for f of x, but now we're asked to find the derivative using the product rule. So for my product, I have x squared plus 2x as my first factor, and I have x minus 3 as my second factor. And according to the product rule, f prime of x equals the derivative of the first, the derivative of x squared plus 2x, is 2x plus 2. So derivative of the first times the second plus the first times the derivative of the second. The derivative of x minus 3 is just 1. Now we're going to simplify this. So again, I'm going to distribute or FOIL this out. So 2x times x is 2x squared. 2x times negative 3 is negative 6x. 2 times x is plus 2x, and then 2 times negative 3 is negative 6. And then we will add our x squared plus 2x. Like terms, I've got 2x squared plus x squared, so that's going to be 3x squared. Then I have negative 6x plus 2x, that's minus 4x. Oh, and I forgot this plus 2x over here, and then minus 6. So let's try that again. It's 3x squared minus 2x minus 6. So we do get the same answer whether we use the product rule or expand to a polynomial and then use the power rule. Number 16, find f prime of x for f of x equals x squared plus 2 times the quantity x squared minus 2x. So we have the option of expanding this, writing it as a polynomial and then using the power rule, but let's go ahead and practice using the product rule. So my first factor is the x squared plus 2, and my second factor is the x squared minus 2x. Okay, so I want f prime of x, the derivative of the first, so derivative of x squared plus 2, and that's just 2x, times the second, x squared minus 2x, plus the first factor, x squared plus 2, times the derivative of the second factor. The derivative of x squared minus 2x is 2x minus 2. And if we simplify this, I'm going to distribute the 2x. I get 2x cubed minus 4x squared. And then for this second term, I'm going to need to FOIL that out. So I get 2x cubed, and then the outer product minus 2x squared, inner product plus 4x, and then last times last is minus 4. Combining like terms, so you have a 2x cubed and a 2x cubed, so that's 4x cubed. And then I have a minus 4x squared minus 2x squared, that's minus 6x squared, and then plus 4x minus 4. Number 17, find y prime for y equals x cubed minus 3x times the quantity 2x squared plus 3x plus 5. So slightly different notation, but we know this still just means to find the derivative. And this is the product of two functions, so let's use the product rule. My first factor for product rule is x cubed minus 3x, and my second factor is the 2x squared plus 3x plus 5. Okay, so y prime equals derivative of the first, it's 3x squared minus 3, times the second, 2x squared plus 3x plus 5, plus the first, x cubed minus 3x, times the derivative of the second, 4x plus 3. Okay, now to simplify this, I have a lot of distributing to do here. I'm going to distribute the 3x squared here. So that's 6x to the fourth. And then here, that's going to be 9x cubed. And then the 3x squared times the 5 is going to be plus 15x squared. And then I'm going to distribute the negative 3. So negative 6x squared, negative 9x, negative 15. Plus, and now I'm distributing over here. So I get, that's 4x to the fourth. And then 3x cubed minus 12x squared minus 9x. Okay, it looks like we've got a bunch of like terms we can combine. So I have 6x to the fourth and a 4x to the fourth is 10x to the fourth. Then we have 9x cubed and 3x cubed. So that's 12x cubed. I have 15x squared minus 6x squared. So that's 9x squared. Minus 12x squared is negative, nope, that was a positive 9 and a minus 12. Yeah, so that's negative 3x squared. Then our linear term, we've got minus 9x, so that's negative 18x, and then minus 15. And number 18, find dy dx for y equals cube root of x times the quantity x squared plus 4. So I'm going to use the product rule again here. The first factor is cube root of x, and the second factor, x squared plus 4. So dy dx, another notation for derivative, equals derivative of the first. So I want the derivative of the cube root of x. And the cube root of x I can think of as x to the power 1/3. So using my power rule, that's going to be 1/3 x to the negative 2/3. Okay, so that's the derivative of the first. Times the second, x squared plus 4, plus the first, cube root of x, times the derivative of the second. Derivative of the second is 2x. So if we want to simplify here, I'm going to distribute. So I have 1/3, and then I'm going to add my exponents. So x to the power, now it's negative 2/3 plus 2. So that's 1 1/3 or 4/3. And then I'm distributing here. So I get plus 4/3 x to the negative 2/3 plus, and then remember this is, cube root of x is the same as x to the 1/3. So I have 2x to the 1 plus 1/3, which is 4/3. And then I have like terms here. Two of my terms have x to the 4/3. So I'm going to add these coefficients since these are like terms. 2 plus 1/3 is 7/3. X to the 4/3 plus 4/3 x to the negative 2/3. Number 19, let f and g be differentiable functions for which the following information is known. F of 2 equals 5, g of 2 equals negative 3, f prime of 2 equals negative 1/2, and g prime of 2 equals 2. Let h be the new function defined by h of x equals g of x times f of x. Determine h of 2 and h prime of 2, then find an equation for the tangent line to y equals h of x at the point 2 comma h of 2. So we have our equation h of x equals g of x times f of x. So to find h of 2, we simply substitute 2 in for x. We get g of 2 times f of 2. G of 2 is given as negative 3, and f of 2 is given as 5. So that has a value of negative 15. H of 2 equals negative 15. So we know our point of tangency is 2 comma negative 15. Now we want to find h prime of x. Since h of x equals g times f, we're going to use the product rule to evaluate the derivative. So derivative of the product is derivative of the first, so g prime of x, times the second, f of x, plus the first, g of x, times the derivative of the second, f prime of x. And now to find h prime of 2, we substitute 2 in for x. So I want g prime of 2 times f of 2 plus g of 2 times f prime of 2. So g prime of 2 is 2 times f of 2, which is 5, plus g of 2, which is negative 3, times f prime of 2, which is negative 1/2. So this is 10 plus 3 over 2. Or 20 over 2 plus 3 over 2, so 23 over 2. And that's going to be the slope of our tangent line. So the slope of our tangent line equals 23 over 2. We can use this information right here, to write the equation of our tangent line. So our equation will be y minus negative 15, or y plus 15, equals 23 over 2 times x minus 2. Number 20, consider the functions r of t equals t to the power t and s of t equals arc cosine t, for which you're given the facts that r prime of t equals t to the t times the quantity ln t plus 1, and s prime of t is negative 1 over the square root of 1 minus t squared. We restrict our interest in both functions to the domain t strictly between 0 and 1. Part A, let w of t equal t to the t arc cosine t. So that is the product of r and s. Determine w prime of t. So we're going to use the product rule here. W prime of t is the derivative of the first, and the first is the t to the power t. So the derivative of that is r prime of t, or t to the t times ln t plus 1. Okay, so that's just derivative of the first, and then we have to multiply that by the second, arc cosine t, plus the first, so that's t to the t, times the derivative of the second, and the derivative of arc cosine t is given to us as negative 1 over square root 1 minus t squared. So that's my derivative using the product rule. And in part B, we want to find an equation for the tangent line to y equals w at the point 1/2 comma w of 1/2. So to find the slope of the tangent line at the point where t equals 1/2, we're going to find w prime of 1/2. So we need 1/2 to the power 1/2 times the natural log of 1/2 plus 1 times the arc cosine of 1/2 plus 1/2 to the power 1/2 times negative 1 over the square root of 1 minus 1/2 squared. Then using our calculator to get a value for w prime of 1/2, we get negative 0.589. So that's going to be the slope of our tangent line. Now to find the point of tangent C, we know the t value is 1/2. So to find the w of t value, we're going to find w of 1/2. So w is over here. We need 1/2 to the power 1/2 times our cosine of 1/2. And again, using our calculator and making sure we're in radian mode, that's going to equal 0.7405. Okay, so again, this is the slope of our tangent. And then this is the y coordinate for our point of tangent C. So our equation will be y minus 0.741, if we want to round to 3 places, equals negative 0.589 times x minus 1/2. Number 21, let functions p and q be the piecewise linear functions given by their respective graphs below. Let r equal p times q. Determine r prime of -2 and r prime of 0. So in order to do that, first we need to find r prime of x. We're going to use the product rule. So r prime of x equals p prime of x, q of x, plus p of x, q prime of x. R prime of -2 will be p prime of -2 times q of -2 plus p of -2 times q prime of -2. So p prime of -2, that's going to be the derivative of the graph of p when x is -2. So I'm looking here and finding the slope of that line. The slope is -2 at that point. So p prime of -2 is -2. Next we want q of -2. Q of -2 is right here. We're reading that from the graph. It's -1. Plus p of -2. So p of -2 at this point right here is 1 times q prime of -2. So right here, the slope is +2. No, +3. Up 3 over 1. Okay, so -2 times -1 is 2, plus 1 times 3, 3. 2 plus 3 is 5. Now r prime of 0 is going to equal p prime of 0 times q of 0 plus p of 0 times q prime of 0. So p prime of 0, let me change colors here. P prime of 0 will be the slope of p at 0. So the slope here is 1/2. 1/2. And then q of 0 will be the value of q at 0, so that's 2, plus p of 0. P of 0 is -1/2. Q prime of 0 is the slope here, which is 0. So that's going to just equal 1 after we simplify. Part B, are there any values of x for which r prime of x does not exist? If so, which values and why? Well, that's going to be where our graphs are not differentiable. So if we think about the equation for r prime of x right here involves p prime of x, and p prime of x is undefined right here at -1 and right here at 1. So -1 and 1, p prime does not exist, therefore r prime can't exist. And then we also have, as part of r prime, q prime of x over here. So wherever q prime of x doesn't exist, then r prime won't exist. And q prime does not exist here at -1, and here at 1. So those are the same corner points for P and Q. And part C, find an equation for the tangent line to y equals r of x at the point 2, comma r of 2. So we've already found r prime. We want to find r prime of 2. R prime of 2 is p prime of 2 times q of 2 plus p of 2 times q prime of 2. So p prime of 2. P prime of 2 with this point right here, the slope at this point right here. So that's going to be a positive 2. Q of 2. Q of 2, that's the pink graph. At 2, the value of Q is equal to 1. Plus P of 2. So P of 2, that's the yellow graph. We're reading that point right there is equal to 2. And Q prime of 2, so now we want the slope of Q at 2, that is negative 1. And when we simplify this, we just get 0. Our prime of 2 equals 0, so that's the slope of our tangent line. The slope of our tangent line is just 0. And then the point of tangency, we need to find r of 2. R of 2, so now I'm looking here at the rule for r of x. R of 2 equals P of 2 times Q of 2. And P of 2, we said was 2. Let's just double check that. P of 2 is 2. Yep, I'm looking right there. And then Q of 2 is 1. So P times Q at 2 is just equal to 2. So my point of tangency is 2, 2. And that means the equation of my tangent line will be y minus 2 equals 0 times x minus 2, or just y equals 2. Use the table below to answer the following questions. If h of x equals 2f times g, what's the equation of the tangent line when x equals negative 1? So we need to find h prime of x. H prime of x equals, and for this I'm going to use the product rule, and I'm going to think of 2f of x as my first factor, and then g of x as my second factor. So I want derivative of my first, which is 2f prime x, times my second, plus the first times the derivative of the second. Now h prime of negative 1 equals 2 times f prime of negative 1. F prime of negative 1, I'm reading from the table, is negative 2. Times g of x, so g of negative 1. G of negative 1, we're reading from the table, is 1. Plus 2 times f of negative 1. F of negative 1 from the table is 3. And g prime of negative 1, g prime of negative 1 is 1. So this gives us negative 4 plus 6 equals 2. H prime of negative 1 is 2, so that's going to be the slope of my tangent line. Now I'm also going to need to find h of negative 1 to get the point of tangency. So that's 2 times f of negative 1 times g of negative 1, or 2 times f of negative 1 is 3 times g of negative 1. G of negative 1 is 1. So that gives us 6. And then the equation of our tangent line, y minus 6 equals 2 times x minus negative 1, or x plus 1. Part B, if j equals g of x times sine x, what's the value of j prime of 0? So we'll use product rule to find j prime of x. J prime of x equals the derivative of the first, so g prime of x, times the second, sine x, plus the first, g of x, times the derivative of the second. Derivative of sine x is cosine x. Now we want j prime of 0, so I'm going to substitute 0 in for the x. So g prime of 0 times the sine of 0 plus g of 0 times the cosine of 0. G prime of 0 is negative 3. So negative 3 times the sine of 0 is 0, plus g of 0 is negative 2, times the cosine of 0, which is 1. So this is just equal to negative 2. And part C, if k equals 4x minus f times 2g minus 2, what is the slope of the normal line? So we want to be careful there. The normal line when x is negative 2. So let's find k prime of x using the product rule. So for my product rule here, my first factor is 4 minus f of x, and my second factor is 2g minus 2. So derivative of the first will be 4 minus f prime of x times the second, 2g of x minus 2, plus the first, 4x minus f of x, times the derivative of the second, that's 2g prime of x. We want to know the slope of the normal line when x is negative 2. Well, let's find the slope of the tangent line when x is negative 2. So that would be k prime of negative 2. We're substituting negative 2 in for x. So we get 4 minus f prime of negative 2. F prime of negative 2 is negative 1. Times 2 times g of negative 2. G of negative 2 is 2. So 2 times 2 minus 2 plus, and then 4 times negative 2 is negative 8, minus f of negative 2. F of negative 2 is 1, times 2 times g prime of negative 2. G prime of negative 2 is 4. All right, so we've got 5 times 2 plus negative 9 times 8. So we have 10 minus 72 equals negative 62. That's the slope of our tangent line. So the slope of the normal line is going to be the opposite, so positive, reciprocal, 1 over 62. 23, find the slope of the normal line drawn to the graph of each function at the indicated value of x. So part A, we have g of x equals the square root of x times the sine of x. So let's find our derivative, g prime of x. We're going to use the product rule. So derivative of the first, my first is this just square root of x. So derivative of the first is 1 over 2 root x times the second, so times sine x, plus the first times the derivative of the second. The derivative of sine x is cosine x. Now we want to evaluate that at pi. So we get 1 over 2 times the square root of pi times the sine of pi plus the square root of pi times the cosine of pi. Well, the sine of pi is 0, so that whole term becomes 0. And then the cosine of pi is negative 1. So here we just get negative square root pi. That's the slope of our tangent line. So for the slope of the normal line, we want the opposite reciprocal, or 1 over square root of pi. Part B, h of x equals sine x times sine x plus cosine x. So I'm going to use the product rule to take the derivative. My first factor is sine x. My second factor is sine x plus cosine x. So my derivative, h prime of x, equals derivative of first is cosine x times the second, sine x plus cosine x, plus the first, sine x, times derivative of the second. The derivative of sine x plus cosine x is cosine x minus sine x. We're going to evaluate this at pi over 4. So we need cosine pi over 4 times sine pi over 4 plus cosine pi over 4 plus sine pi over 4 times cosine pi over 4 minus sine pi over 4. Cosine of pi over 4 is 1 over root 2. Sine of pi over 4 is also 1 over root 2 plus 1 over root 2 plus 1 over root 2 times, it's getting repetitive, 1 over root 2 minus 1 over root 2. Well, this is nice. 1 over root 2 minus 1 over root 2 is 0 times 1 over root 2, so that whole part of it goes to 0. And now we have 1 over root 2 times 1 over root 2 plus 1 over root 2 is 2 over root 2. And that gives us 2 over 2, or just 1. Now that is the slope of the tangent line. So the slope of the normal line is going to be the opposite reciprocal, or in this case, -1. 24. For each of the functions below, find the equation of the tangent line drawn to the graph of g of x at the indicated value of x. So to find the equation of the tangent line, we need to know two things. For part A, we need to know g of 4, and then we need to know g prime of 4. So let's start by finding g of 4. G of 4 is just square root of 4 times 2 times 4 squared minus 4. So that's 2 times 28, or 56. Now we want to find g prime of 4. So first we find g prime of x. G prime of x, we're going to use the product rule. So the first factor is square root of x. Derivative of the first is 1 over 2 root x times the second, 2x squared minus 4, plus the first times the derivative of the second is just 4x. So now to find g prime of 4, we just substitute 4 in for x. So get 1 over 2 times the square root of 4. That's 1/4. 2 times 4 squared, that's 32, minus 4 is 28, plus the square root of 4 times 4 times 4. Okay, so 1/4 times 28 is 7, 2 times 16 is 32, so that's giving me 39. Okay, so the point of tangency, 4, 56, and the slope of my tangent line, 39. So my equation is y minus 56 equals 39 times x minus 4. And part B, g of x equals x squared cosine x. So again, we need product rule here to find that derivative. G prime of x equals derivative of the first times the second plus the first times the derivative of the second. G prime of pi over 2 will be 2 pi over 2, or just pi, times the cosine of pi over 2. The cosine of pi over 2 is 0, so that's going to drop out, plus pi over 2 squared, it's pi squared over 4, times negative sine of pi over 2. So that's going to become a -1. So we just get negative pi squared over 4. That's the slope of the tangent line. Then we need to find g of pi over 2 to get the point of tangency. So g of pi over 2 is pi over 2 squared, so pi squared over 4, times the cosine of pi over 2. But the cosine of pi over 2 is 0, so that's just 0. So now our point of tangency, pi over 2 comma 0, and the slope of our tangent line, negative pi squared over 4. So our equation, y minus 0 equals negative pi squared over 4 times x minus pi over 2.